Okay, here is the third video. Here's the big deal about the third video. Now, the tricky part on these last problems we're going to give you for reflections, right? Reflection is pretty easy, right? But on these last problems, they're going to ask you now not to reflect on the x-axis or any horizontal line, or not to reflect the y-axis or any vertical line. They're going to give you a diagonal line. So one of the lines they might ask you is y is equal to x. The line y is equal to x is the same as y is equal to 1 over 1x, right? Plus 0, right? The slope is 1 over 1, and it doesn't have a y-intercept, right? You're trying to make this look like the equation of a line, right? Y is equal to mx plus b. But long story short, if you have the line y is equal to 1x or y is equal to x, you start at 0, and remember the slope is 1 over 1, so you're going up 1 over 1 dot, or you have a dot, you start at 0. 1 over 1, 1 over 1, 1 over 1, and you see 1 over 1 is just going to give you this pretty much exact diagonal line. And it's continuous, so you go this way, and this is the line, y is equal to x. Right? Oh, I don't have a ruler. I should have a ruler, but I'll try my best. Ooh, that's pretty good. That's the line y is equal to x, okay? That's the line you're going to do a reflection on, and this is going to be a different story. Okay, so I'll talk about the other line is going to be y is equal to negative x. I'll talk about that one down here. Y is equal to positive x is this way. It's a diagonal line going through this way. Okay, so if you're reflecting a point, let's say point A, I'm going to pick a point A. Let's say this is point A right here. Let me zoom in here. Now, how do you do this? How do you do this when the line's like a diagonal line? Well, it's a little tricky, but it's easy. For a diagonal line, you are going to, if I have to reflect this point, again, that's almost like I have to fold it this way, like you're folding it along the line this way. It's a little tricky. But long story short for you, since it's an exact diagonal line and it's 45 degrees, but that doesn't matter right now, all you have to do is, you don't just count up to the line and count up like this again. That's wrong. That's only if it's horizontal or vertical. You have to count 1, 2, 3, 4. Everybody agree it's 4? And then you go not 4 up, but remember, because it's diagonal, you go the other way now. 1, 2, 3, 4. That would be the image of A. When it's a diagonal line like this, you count whatever it is to the line, and you don't count the same way the other way. That's only for vertical or horizontal lines. Then you count the other way like that. And if you can see where that point is, if I were to do a reflection, if I were to actually fold it, that's where the point would land. I can't fold it that good, but that's the correct reflection of this point over that line. It would be right there. It wouldn't be up here. Okay? That would be the coordinates. Okay. Now, another thing I want you to notice, if this point A was, the coordinates is -2, what? -6. Notice what the coordinates are going to be for this one. Now this one's what? -6, -2. So long story short, guess what? -2, -6, all what happened is what? These coordinates flip. See? That's because it's an exact diagonal line. So the image is going to be, the coordinates just, this one's x, this is y. Now this one's x over here, this one's y over here. That's a quick way to figure it out. Okay. And the same thing if you have a shape, right? Let's just go with a triangle again here. Let's say if I have this shape right here, boom, 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 this triangle right here. Let's call that DEF. Points DEF. Sorry, right there, DEF. Where D is what? D is 2, 9. F is 2, 6. Oh, actually, let me go E. E is 6, 9. And F is 2, 6. Well, what did we learn over here? For these diagonal ones, what happens to this? If it's, you just switch, but we'll see if that's true. I'm gonna count down 1, 2, 3, 4, and I'm gonna go 4 this way, and then I'm gonna go 4 the other way. 1, 2, 3, 4. This will be F. Prime. This will be what? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And this will be what? Oh, I put this in the wrong place. 1, 2, 3. So 1, 2, 3. This is the way it would look. Right? So just imagine if this were a fold over like this and you'd fold it on that line, is that the way it would look? Yeah, it would. That's a reflection. Right? So that's D, then this is E, right? And let's see, according to this, according to what we learned over here, if I do a reflection, all you do is you switch the numbers. So let's see. E is now going to be 9, 6. I'm sorry, E prime. Is that, I'm sorry. Right? E is now 9 on the X, 6 on the Y. And that's E prime. And so now see, 9 on the X, 6 on, yes, it's true. The numbers just switch. How about this one? F prime would have to be what? Well, if this is 2, 6, is this going to be 6, 2? Let's check. F, oh, 6, 2. That's right. And if D is 2, 9, then D prime would have to be what? A 9 and a 2? Let's check if that's true. D prime, 9, 2. All right. But what I wanted you to see is how you count to the line. But since it's diagonal, you go, if I go down, then the next one's across. If I go down, then the next one's across. All right. Let's see this other line. And we'll just see one example of this. What if you have to graph, and the last one is they're going to say graph it along the line y equals negative x, negative x. Well, if this diagonal is positive x, the graph for y equals negative x is the diagonal line going this way. Because the slope is down 1 over 1, down 1 over 1, down 1 over 1. So long story short, it's a diagonal line this way. That's the line y equals negative x. Okay? And let's just reflect this shape here. Let me go from here. I'll just make up any triangle. And this will be x, y, z. And the coordinates of x that I can see here is negative 2, negative 2. The coordinates for y is negative 8, negative 4. right? Negative 8 on the x, negative 4 for y. And the coordinates for z is on the x, negative 1, negative 6. All right, let's see what's going to happen when y equals to negative x. Well, again, you do 1 point at a time. 1, 2, 3, 4. So 1, 2, 3, 4. 4 up, that means 4 across. This will be x prime. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And oh my God, this is going to be far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 from here to here, that means I got to go 12 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew. Okay, no, it doesn't look like it, but this is the reflection along the line y is equal to negative x. Okay, so remember this one was x prime, this one was y prime, and this one's z prime. And let's look at the coordinates. 2, 2. 2, 2. X prime is 2, 2. Oh, what happened? They didn't just switch. I think the signs just changed. I don't know. Let's see the other one. Y. Y prime is what? This will be positive 4, positive 8. Positive 4, positive 8. Okay, so this is what's happening. They are switching and the signs switch, right? Because of the negative, it switches the sign. So you do switch them, just like we switched them here, switch the x and the y, but because of the negative, you also change the sign. Let's look at z. Z is, what is it? Oh, it was negative 1, negative 6, so here it's going to be 6, positive 1. Yeah, see, so we switched them and switch the sign because of the negative. 6, positive 1. Okay, so that's how you do the reflections along the line y equals negative x, right? You count to the line and don't count the same way. You got to change the direction. And then when it's y is equal to x, you just switch the x and the y. You don't change the sign, right? We saw that here. This was 2, 9. This is 9, 2. This was 6, 9. This is 9, 6. But when it's a negative x, we do switch the numbers, you do switch them, and you also change the sign. All right. There it is. All right, good luck, you guys.